Right, so in this video I'm going to have a look at the Leaving Cert Higher Level Maths Paper 1, 2017, and particularly I'm going to have a look at questions 2 and 3. So this is question 2 here. We're given a complex number here in rectangular form. It's minus root 3 plus I, where I squared is minus 1. And we've got to use de Moivre's theorem to write z to the power of 4. So we've got to raise this complex number to the power of 4 here and write our answer in this format here. So what we need to do here is to use de Moivre's theorem. We've got to convert this to polar form first. So what we need is to work out the modulus first and then theta. So to work out the modulus here, this is our complex number here. We want the modulus of z, so that's the modulus of minus root 3 plus I. That's just the square root of a squared plus b squared. So our a here is minus root 3, so we've got to square that. Our b here is plus 1. That's the coefficient of the I here. So if you square minus root 3, you'll just get plus 4. No, sorry, you'll get plus 3. If you square 1, you'll get 1. So we end up with plus 4 here. So it's the square root of 4, which is 2. So that's our modulus. Now to work out the angle that we're talking about here, let's just move this up a little bit and just have a look at the angle that we're talking about here. Well, if you take our complex number minus root 3 plus I, minus root 3 plus I here, well, it's going to be in the second quadrant here. It's going to be up, it's going to look something like this. It's going to be up in this direction here somewhere. So the angle that we're actually looking for is this angle here. This is going to be the angle that we're going to put into our polar form. However, what we're actually going to look at first of all is our angle alpha here. It's the angle that our complex number here makes with the x-axis. So I'm just going to work out what this angle is here. If I can work out this reference angle here, I'll be able to work out what theta is. So let's do that. Well, we can see here that we're going to go out here minus root 3, so this is going to be I'll just write down the positive value here. It's going to be root 3 in this direction, and it's going to be 1 unit in this direction here. So if we take the tan of alpha is going to be 1 over root 3. 1 over root 3. If we just take this triangle here, the tan of our angle, this green alpha here, is going to be 1 over root 3. That means our angle alpha then is going to be tan inverse 1 over root 3. So the angle, in other words, what angle has a tan of 1 over root 3? And we'll find that our angle is actually pi over 6. Pi over 6 here. Or 30 degrees. So this is going to be 30 degrees here, or pi over 6. So what does that make our angle here? Well, we know that this is pi out as far as here. From here out to here is pi, which is really 6 pi over 6, and we're 1 pi over 6 back, if you like. So really the angle theta here is going to be 5 pi over 6. So in other words, theta then is going to be 5 pi over 6. 5 pi over 6. Okay, so now we have our angle and we have our modulus, so we can write our complex number in polar form. So in other words, z then in polar form, z is equal to minus root 3 plus I, and in polar form then it's going to be or cos theta plus I sine theta. So our or is 2, so it's going to be cos 5 pi over 6 plus I sine 5 pi over 6. Okay, so this is our z here. Okay, this is our z in polar form. So what we've got to do is use de Moivre's theorem to write z to the power of 4. This is what we've got to do here, z to the power of 4. So let's do that down here. Okay, so we want z to the power of 4. So that's just going to be our 2 cos 5 pi over 6 plus I sine 5 pi over 6. And we've got to raise all of this to the power of 4. So let's do that. Well, 2 to the power of 4 is 16, so that's just going to be 16. Now we've got to raise this here to the power of 4 as well, but using de Moivre's theorem it just means you multiply the angle by the power here, or you can drop this number here in front of the angle here and multiply. So it's going to be cos 10 pi over 3, in fact 10 pi over 3 plus I sine 10 pi over 3. Because if you take your 5 pi over 6 and multiply it by 4, you'll get 20 pi over 6, which is just 10 pi over 3. So that's where I get this 10 pi over 3 here. Okay, so this is our complex number here, so in polar form. So it says that we've got to write this in rectangular form, or in the form a plus b root ci. So let's have a look at this here. This is 10 pi over 3. I'll just move this down a little bit. Just give myself some room here. Okay, so we have this 10 pi over 3 here. We've got to work out the cos of that. So if you take, let's just have a look at, I'll do it over here. So if we take 10 divided by 3, it goes in 3 times. So we're going to have 3 pi's and 1/3 of a pi as well. So in other words, we're going to go around 2 pi, and then we're going to be left then with 1 1/3 pi left over. In other words, really what we're going to be looking at here is the cos of 4 pi over 3. 4 pi over 3. So really what I'm going to be looking at here is 16 times cos 4 over 3 pi plus I sine 4 over 3 pi. Because there's a 2 pi and 10 divided by 3, we're going to go all the way around here once, which is 2 pi, and then we have a 4 over 3 pi left over. So what's 4 pi over 4 pi over 3? Well, that's going to be 1 1/3 pi. In other words, pi is out here and we want 1 1/3 pi. This is 1 pi, so we're going to end up down here somewhere this time. So we want this reference angle here. Let's call it alpha again. So this angle here is in fact going to be pi plus another 1/3 pi. So this angle alpha here, is in fact going to be pi over 3. So this angle here is pi over 3. This is our reference angle here. So if you take the cos of pi over 3, the cos of pi over 3 is a half. But remember, we're in the 3rd quadrant here, and cos is going to be negative in the 3rd quadrant. So it's going to be minus half plus I times sine 4 over 3 pi. Well, the sine of 4 over 3 pi is going to be the same as the sine of pi over 3. And the sine of pi over 3 is root 3 over 2. So it's going to be root 3 over 2. However, sine is negative in the 3rd quadrant, so this is going to be negative here. So in other words, our answer will be 16 times minus a half minus root 3 over 2 I. And when you multiply that out, then we end up with minus 16 times a half is just minus 8, and then we'll end up with minus 8 root 3 I here. So this is our final answer here, and this is in the form a plus b root c times I. So that's it really. This is our final answer here. Okay, so let's move on to the next question then. So this is to do with a complex number. W is such that the modulus of W is 3, and W makes an angle of 30 degrees with the positive sense of the real axis. Now we have this other letter here, T, and that's equal to Z times W. We've got to write T in its simplest form. So we've got to multiply these two complex numbers together. So we know that Z here, Z is minus root 3 plus I, and we know that in polar form that's 2 cos 5 pi over 6 plus I sine 5 pi over 6. So this is our Z anyway in rectangular form and polar form here. So what about W then? So you got to look at W. Well, for W we've got the angle, we've got 30 degrees, and we also have the modulus here. So we can write W in polar form as well. So W in polar form is going to be 3, which is the modulus, times cos of the angle, which is 30 degrees, so that's pi over 6. We'll keep it in radians, plus I sine pi over 6. So these are our two complex numbers. So what we've got to do is multiply these two together to find T. So let's do that. So T is going to be equal to Z, which is 2 cos 5 pi over 6 plus I sine 5 pi over 6. We've got to multiply that by W, which is 3 times cos pi over 6 plus I sine pi over 6. Okay, so let's do that. Well, 2 times 3 will just give me 6. Now we've got to multiply these two complex numbers in polar form. And you may remember, to multiply complex numbers in polar form, what you've got to do is add the angles. So in other words, what we're going to do here is write down cos 5 pi over 6 plus pi over 6 plus I sine 5 pi over 6 plus pi over 6. So this is the multiplication of complex numbers in polar form. So this will give me 6 times cos, well, 5 pi over 6 plus pi over 6 is 6 pi over 6, which is just pi. And here we've got I sine 5 pi over 6 plus pi over 6, 6 pi over 6, which again should be just the same as the other one, which is pi. Okay, so now we just simplified this, so it's got we've got the cos of pi. The cos of pi is minus 1, and this should be plus I sine pi. So here we have the sine of pi. The sine of pi is just 0. So when you multiply this out here, you'll just end up with minus 6. And that's about as simple as you can get it. We were told to write it in its simplest form. So that's it. That's the answer. You could also do this by multiplying out the two rectangular forms, but you would have to work out W then in rectangular form. But this is the easier way of doing it, I think. Okay, so let's look at this one here. Again, I'll just move this to give myself some room. This is question 3, and this involves differentiation. So you've got to differentiate this function here with respect to x, and we've got to do it from first principles. Okay, so let's start. So what I'm going to do first of all is just call this f of x. We'll call this function f of x is equal to 1/3 x squared minus x plus 3. So the first step is, if you may remember what we want to end up with is the limit of f of x plus h minus f of x over h as h goes to 0. This is what we want to end up with. This is our definition, if you like, of differentiation. So we're just going to do the top line first, then divide by h, and then let h equal to 0. So this is my f of x here, so this is this part here. Now I'm going to write this out here. So I'm going to do f of x plus h next. So this is 1/3 x plus h squared minus x plus h plus 3. Okay, so we got to just multiply this out. So this would give me 1/3 x squared plus 2xh plus h squared. Here we'll just end up with minus x minus h and plus 3. Just multiply by 1/3 here, so you've got 1/3 x squared plus 2 over 3 xh plus 1/3 h squared minus x minus h plus 3. Okay, so that looks okay so far. So the next thing we've got to do, if you remember, is we've got to subtract these two. So you've got to take this expression here and subtract this expression up here. So let's just write all that out. So what we want next is f of x plus h. We've got to subtract f of x. So I've got to write all this out. So hopefully I'll have room here, but it's 1/3 x squared plus 2/3 xh plus 1/3 h squared minus x minus h plus 3. And we want to subtract f of x. So I'll just put it in brackets here first. So it's going to be 1/3 x squared minus x plus 3. So we've got to subtract that. Now you can see here that we've got a 1/3 x squared here, and we've got a minus 1/3 x squared here. So this one and this one will just cancel each other out. We'll just get 0 here. We've also got a minus x here, but this is minus minus. This is actually a plus x here, and we've got a minus x here, so that will cancel with this one here. We've also got a minus plus 3 here, which is minus 3 and plus 3 here. So what are we left with? So we're left with this 2/3 xh plus 1/3 h squared minus h. Okay, so that's it. Now next step then is to divide by h. So you've got to take our f of x plus h minus f of x, and we've got to divide by h. So if we divide each of these terms in this expression here by h, well, the h will disappear here. We'll just get 1. So it's 2/3 x plus, here we'll end up with 1/3 h, and here we'll just end up with minus 1. Okay, almost there. One more step. Now we've got to find the limit of this. So you've got to find the limit of f of x plus h minus f of x all over h as h tends towards 0. Well, if h tends towards 0 here, this term here will just become 0, and we end up with 2/3 x minus 1. 2/3 x minus 1. Now you can just check that by doing this the quick way, if you like. So our original function, remember, just do it in blue here. Our original function here, f of x, was 1/3 x squared minus x plus 3. And if you do this the quick way, you can see, bring the 2 down here, multiply, so you get 2 over 3x, subtract 1 from the power, so it's the power of 1. Here we'll just end up with minus 1, and this becomes 0. So it does work. We did get the correct answer here. So this is just differentiation from first principles. Okay, last one then I'm going to do in this video is part B, and this involves a function f of x, which is the log of 3x squared plus 2, and we've got g of x, which is x plus 5. Now we've got to find the derivative of this compound function here, f of g of x when x is equal to a quarter. So what we've got to do first is work out what this is. So we want f of g of x. So in other words, we've got to take g of x, which is x plus 5, and put it in here. So really what it is the log of 3 times x plus 5 squared plus 2. So this is our g of x here, and we put it into our f of x here. So let's just multiply that out. That gives me the log of 3 times x squared plus 10x plus 25. We've got plus 2 here as well. Okay, so that gives me the log of 3x squared plus 30x plus 325 is 75 plus 2, 77 there. So this is what we've got to differentiate first, and then whatever we get, we've got to put a quarter in for x. So let's do that. So you've got to find the derivative of this function first. So you got to find the derivative of g of x here. Okay, so let's do that. So the derivative of log x is 1 over x. So to derive this function here, we've got to do 1 over 3x squared plus 30x plus 77. Now we've also got to multiply by the derivative of what's inside the bracket here. So this is using the chain rule really. So if we got to derive what's inside the bracket here, so that will give me 2 3's 6x to the power of 1 plus 30, and this becomes 0 here. So our final answer really here is just 6x plus 30 over 3x squared plus 30x plus 77. Now we were asked to find the derivative of this function up here, this function here, when x is equal to a quarter. So in other words, we've got to stick a quarter in here for x. So let's do that. So at x is equal to a quarter, f of g of x is equal to, so it's going to be 6 multiplied by a quarter plus 30 all over 3 times a quarter squared plus 30 times a quarter plus 77. Okay, so look, this really is just a case of using your calculator to multiply all this out. I'll do it in a couple of steps, but what we get on top here is 63 over 2, and on the bottom what you end up with is 1355 over 16. And look, when you multiply all of that out, you get a fraction 504 over 1355, and then you've got to work that out to 3 decimal places. That's what the question asked. It's very easy to do these questions and leave this as your answer, but you got to go back and read the question as well, just to make sure that you've answered exactly what they've asked you. So they want this to 3 decimal places. So this is really approximately equal to, if you like, to 3 decimal places, 0.372 to 3 decimal places. Okay, so that's it for this video.